Welcome back to the Rust Book Speedrun. We are on Rust Book 4.2, References and Borrowing, and it's just getting good. So let's get into this and see what we have to learn in this lesson. Refs and Borrowing. Okay, we have our example package all set. So we left off with this issue of everything that we want to not destroy in the function we pass a reference into, we have to return. So we'll end up with massive tuples. But the alternative is to provide a reference to the string value. It's a pointer. It's an address we can follow to access the data, but it's owned by some other variable. Similar to a pointer, unlike a pointer, it's guaranteed to point to a valid value of a particular type. Okay, so if we dereference a reference, we don't have to worry about whether it's valid memory. That's nice. So we can pass a reference, and we note that it is a reference, and we don't lose it. Let's try it. And len is not a reserved word. How nice. Reference to S1. Okay, let's try it. And it works. Now, if we change this to not be a reference, then we get the error, do we not? S will go out of scope. Yeah, borrowed here after move. Wow, it even traces back to exactly where you would have to change it. And we can alternatively clone it, which is a big waste of memory. And that works too. Interesting. Okay, so that works. I'm going to move on. No more tuple code. Dereferencing, don't even think about it until chapter 8 and 15. Okay, so ampersand creates a reference. And if you have a parameter with the ampersand, it means it should be a reference of that type. S, the reference goes out of scope. Well, S does go out of scope, but it doesn't have ownership of what it refers to, so what it refers to is not dropped. Okay, so S is scoped the same as anything else, but the thing it points to is not dropped when it goes out of scope because it doesn't have ownership. Creating a reference is borrowing. We can't modify borrowed values. Does this even compile? No. Oh, it's immutable. Cool. Variables are immutable by default, so are references. Okay. Uh-oh. Mutable references, so there's an exception to the rule. And mutable, ampersand mutable, mutable reference. Okay. So if we change this and we say ampersand mutable string, mutable reference to S, we should see hello world. Yep. One big restriction, you can have only one mutable reference to a value. So if we do this, it fails, but what if we drop in between? First of all, does that work? Yes. Second of all, does this fail? No. Oh, I think that put R1 out of scope, so if we try to do this, that's what'll actually cause the problem. Yes. So we're actually implicitly doing this. So even if I do this, well, that'll really mess things up. But yes, we're implicitly dropping because of this guy. We can't use R1 anymore after that happens. Okay, so we can do mutation in a very controlled fashion. New rustaceans such as me struggle with this. I am prepared to struggle. Data races. It prevents data races. Two pointers with access to the same data, one of them being used to write the data, nothing used to synchronize access. Undefined behavior. That's not good. Cool. Thanks, Rust. So we can have multiple mutable references in different scopes because one goes out of scope and then you're fine. Cannot borrow is mutable because it's borrowed as immutable. It really tracks this stuff. You can't get one past it, can you? Okay, that makes sense. If you have an immutable reference, you don't want it changing. So the last usage of the mutable reference occurs before the mutable one is introduced. That makes sense. So these both go out of scope or whatever, they get destroyed, and then we're allowed to take a mutable reference. That's so cool that it's at compile time. Very nice. Dangling references. Compiler guarantees no dangling references. Okay, I might have to write this out to understand why it's a dangling reference. Returns an immutable string reference. We create a string, immutable. We return a reference to it, immutable. And then we try to say dangle. Oh, because S goes out of scope and then we return the reference to S as S goes out of scope. Interesting. It tells me to add a lifeline. So that's chapter 10. Return type contains a borrowed value, but there's no value for it to be borrowed from. It returns a reference to a string. S is a string. Return a reference to S. S goes out of scope. Its memory goes away. Danger. Okay. So instead, we return string directly. And okay. So you can have either one mutable reference or any number of immutable references. References must always be valid. No dangling. Okay. A different kind of reference, slices. Whoa. All right, well, that's it for this one. Hope you enjoyed. See you for the next Rust book speed run.